Thank you. Yes, this is one of the few talks where I did not worry about the fit between my talk and the talk. Fairly sure that they were quite aligned. So I'm going to talk to you about the ERYOR grant, the ERYOR project that we are running mostly at the University of Bern. So who are we? It's myself, it's Malte Elson, it's Ruben Arslan, who's not here, who are the PIs. I'm the chief recommender, which is a type we had to make up, and I will explain. We also have an advisory board, which we will come back to later on in the talk, and it's all the usual suspects that you might suspect in open science and early detection, and we're very grateful for their help and participation. Okay, so let me open by saying, because I really regretted when I read the abstract I had written for this, I sort of said something, I won't repeat it, that's repeating the problem. But I felt like I didn't convey what I meant. What I meant was, we ask too much of peer review. It is not fair to ask peer review to hold the burden of scientific scrutiny for all of us on its shoulders like Atlas. It is an imperfect process, it's a necessary and important process, but it is imperfect. It is a one-shot process usually with little redundancy, despite the fact that it has imperfect reliability, the fact that things change over time. Our knowledge updates, our practices update. But once things are published, they're published forever with some very rare exceptions. It's generally not a very technical process, and it has surprisingly little error checking in it. And for an industry that bases itself on the idea of unveiling truth, this is strange. I think we should be doing more error checking. I think we all probably do. We're in this room. So let me get this out of the way to say, what do I even mean by an error? This comes up in the context of our project a lot. It's very broadly defined because of, yes, our fields are heterogeneous, our practices are too. This is one kind of pseudo-legal definition. An act that through ignorance, deficiency, or accident departs or fails to achieve what should be done. Shoulds are always a little tricky, but it's an orientating term. And I note that we also think about this term in terms of both provable and probable errors, like long-run error rates, but also you have made an error in your code on line 6. It's provably the case. It goes beyond computational reproducibility, but we're very interested in what the computational reproducibility folk have to say and talk to Lisa and things about this. And also that it is fuzzy, the line between error checking and scrutiny more generally. It's hard not to also drift into the related topics of measurement, of flexibility in analytics and measurement, robustness, things like this. Okay. Who can help us carry this burden? I know you're all thinking the same thing as me. Someone far better at this. The obvious is answer, but it's not yet workable. We can't get the ethics. We can't get the thing to work. Clone Nick Brown. Do it all for us. I wish. Nick Brown and his ilk, like Elizabeth Wick and many others, many of them who go unnamed, some of whom are here among us but don't get credited for these things, sometimes because of reputational things, are cool, I think. I think they are like the punk rock of science. I think they're incredibly valuable. They always remind me of my favorite line from my favorite film about how these errors tend to get spotted. They do what nobody else did. They looked. They are so valuable to us, and I find myself thinking about how valuable these individuals are, that I went from like, this is cool, these people are doing such important stuff, to we have a really big problem because they're too valuable. There are too few of them, and we are too reliant on them. When thinking about this, I thought a lot about the lessons we could learn from the open science movement, the methods reform movement, however you want to call it, over the last decade. Hard-won lessons, and ones that we need to repeat here when applying them more specifically to error checking, right? Thought leaders and experts are very important. Certain individuals get things done, right? We have a huge debt to them. You know, Brian, Samin, so many of you in this room, right, have contributed in these ways. But reliance on these few diligent experts is a structural weakness. We can't ask them to just swap out peer review for an army of Nick Browns or Dan Lackens or whoever, you also need a grassroots ECR-driven movement. That is one of the fundamental differences that happened after BEM and false positive psychology, is the grassroots movement that sprung up around it. And we need to facilitate this with error checking. We're not yet doing a great job of that. Speaking of errors. Okay. And sometimes you need a big stack of money too, right? Happened with COS, happens elsewhere. We're based in Switzerland. Maybe we can help. These are not my arguments. I've stolen them. Like any very tenured individual, I just took it. Right? They're Brian's arguments. He wrote about this very convincingly. I've seen him talk about it for years. I really buy it. His strategy for the Center for Open Science when building OSF and things like it to increase pre-registration and data sharing borrowed from how technology gets adopted. It's a tiny fraction of people who are willing to do this thing initially. They do it for no money. They do it despite the fact that it hurts their careers. You know, a bunch of weirdos and outsiders, as I said, right? I wish it was even 2.5%. It's a tiny, tiny edge of this tail. It's a fraction of 1% right now. And that needs to change. So I read more of Brian's slides and past talks and what he had written about this. And this was his model. And I think it's a really good one. Make it possible to do, make it easy, make it normative, make it rewarding. Eventually, down the line, hopefully, fingers crossed, make it required. He did this with the CLS, with infrastructure and the experience. Always love the user experience. The communities and the incentives built up around it. So what are we proposing that we might do when it comes to error checking specifically? Well, there's always a standing on the shoulders of Brian. The availability of data and code is what we needed OSF for. We probably couldn't do this, but I'll figure that one. We also need the existence of error detection methods. We cannot invent this all from scratch, right? Things like stat check. Who knows what stat check is? Oh, great. Okay, brilliant. Things like stat check, but many other things too, need to exist in the first place. Before you can do the rest of the steps, first they have to be possible. These things need to exist. Then you can do the make it easy, make it normative, make it rewarding, eventually maybe make it required. So this is the bits we want to fill in. We're not to talk about, we won't get there, but discoverable and usable error detection methods. A lot of them exist. A lot of them aren't that friendly to use or even fun by. More teaching in communities to make these things normative and make it rewarding through error rewards, which I will explain. So I'll talk about each of these three middle bits that this project attempts to contribute to within error detection. Make it easy, make it normative, make it rewarding. First off, make it easy. We will increase the discoverability and usability of error detection methods. If you are a little bit familiar with StatCheck, you know of the type of thing I'm talking about, but just in case, I'll cover my bases for everyone. These are methods to scrutinize. It could be the article, the data, it could be the code, it could be the interrelationships between them. I'm mostly going to talk about article-based methods here, but we need all of them, right? Image forensics, all of them. There are generally smoke-burst methods and fire methods. What I mean by that is some of them you might look at because it is at the center of the author's test of their hypothesis. And if that's wrong, that's a big problem. Other ones might be very, very peripheral things like, did they get the demographics summaries right? Why would you want to look at that? Because sometimes if things aren't right there, it's a good reason to go further. They're very cheap, easy, quick to look at. And sometimes where there's smoke, there's fire. So smoke methods and fire methods. Usually these methods, when they are invented, and many have over the last decade, they involve very simple math, often, not always. They tend to exploit overlooked details and repetition of information inside a paper, such as in StatCheck. And they often use very well-established principles rather than newly invented ones and redeploy them for the purpose of error detection. And it's fascinating how this can be done. And I think we need to do it more. So where would I go if I wanted to know how to do this? What book would I pick up? The scientific article as a genre is very well established. Right? If you Google this, if you want to depress yourself, as I do, Google like how to write a scientific article. You will get offered dozens of books, dozens of articles about writing articles. There's a lot of material out there. We teach our students to do it all the time. We train our mentees up to do this. It is a well understood genre. You know how to read it, you know how to write it. 30 years ago, Hyman wrote that there is no handbook for writing replies. He meant like post-publication critiques. And I haven't found anything in the meantime. 30 years. If you Google how to critique a published article or what do I do if I find errors in a published article, guess what you get? You get the same books on how to write the articles in the first place. And a few ResearchGate comments about like, oh, just email the authors and they'll correct it for you. So there is no handbook for this. Maybe we need to write one. I think that would be an obvious outcome of this ERYOR project. And we would need everyone's help to do this. So to give you some examples of methods, you know StatCheck. I'll say it does up the slide. Anyway, StatCheck uses redundancies in the information. Everybody tends to focus on p-values and forget that these things here are important too, despite the fact that they represent the same information. So you can recalculate the p-value from the degrees of freedom, the t-value, and find, oh, they don't match, an error. Something could be done about it. Does anyone know GRIM? Always fewer and fewer hands as I go through these, right? The most popular methods people know, but rapidly it trails off because poor usability, poor discoverability. GRIM tests for issues with means, and this is kind of one of the simplest examples I can give you. If you say that you had two people rate a single statement on its believability on a scale from 1 to 5, but I reported a mean score of 2.7, hopefully you can spot that that's not possible. It has to end with a 0 or a 5. This is what James Heathers and Nick Brown spotted, and simply scaled this up and says there is a range of possible values given your sample, not sample size, given your mean and your sample size. The granularity can be checked and tested.
Just as somebody who doesn't know these methods, so is this basically artificial intelligence? So you give the system, it doesn't read, and then knows that this is a mean of two numbers it should look for.
Not, I wish.
How does it do that then?
As in Nick Brown, sits down at his computer and reads it and pulls out the value and takes out a big calculator.
How is that not me computing stuff?
It is.
Okay. So it's not a software where you fill stuff.
It's a method in that it has described maths. There are an R package for it, but the numbers you have to manually extract, right? I'm going to come back and describe this as like shoe leather based methods, where they involve a lot of graph and grind. Yes. Great question. Okay, there are others. There's a Grimmer and a Grimmist. There's also Sprite. Anyone heard of Grimmer, Grimmist, Sprite? Fewer and fewer hands, right? Rivets and Debit. Anyone for Rivets and Debit? I only discovered them in the last few weeks, right? You can also do things like reproduce effect sizes, test statistics from summary stats, sometimes entirely, sometimes you have to make some assumptions. Lisa, you have a great package on this on Within, which I've been playing with. It's very valuable. The point is, the further you go down this list, and I only needed to go like 5 or 6 deep before it was just me and Malta, nobody knows these methods. Nobody knows these methods because we don't have enough R packages, vignettes, how-to guides, blogs, general ways of discovering these and putting them together and using them. So that's what we're doing. I have got a bare bones R package, which is laughable, but like I am no Sasha Epskamp. I am no creator of Levan, whose name escapes me right now. Use for yourself. It's laughable. It's not anything technical. It's just like a set of vignettes on how would I do these things, but all in one place. And this is what we need to flesh out. So that now, if I need to generally do scrutiny or do error detection, I know where to look. say, oh, I wonder what's out there. Makes it discoverable, makes it. Okay. Yeah. Some of them are semi-automated, like stat check. You can just give it a PDF and it'll do the rest for you. But most of them involve a lot more manual work, to the point where once you get to these, what we could call shoe leather error checking methods, are mostly manual, right? You can do some stuff in R, but you generally have to do it yourself. They have a terribly unfortunate lack of acronyms. So how are they ever going to take off? We need to give them some maybe. And these things are so simple and stupid. And that's how I have to train my students. I have to keep saying, you know, what could have gone wrong in this paper? And they're like, oh, what if they misspecified a random effect? I'm like, no. Think like way stupider. Think like just the full sample reported in the article minus the exclusions equal the reported analytic sample. Because when I get 15 students to check 2 papers each, they find more than one paper where it doesn't. Are the means inside the scale range? I had to look at one paper to find this. So if I say the sum scores on the 5-point scale with a response options of between 1 and 7 had a mean of 38.1. And in the case, has to be between 5 and 35. So the smoke, I don't know if there's fire, but the smoke are the point estimates inside the confidence interval. I found a paper riddled with these. Well, a colleague of mine came to me and said, am I crazy? And I said, definitely not. Riddled with these, we approached the journal and we said, hey, this and many other issues we found, the journal was Frontiers, and they said, we've looked into it and everything's. Yeah. Nick Brown is king of tests like this. He is excellent at it, which is why I joke about cloning him. But we've only got one of him, and we need to train a grassroots, ECR-driven, big network of people to do this. And some of this just involves crowdsourcing all of these little things you could check and figuring out what's more and less useful, and then looking at the prevalence of these. Okay. Apart from these shoe leather approaches that you can use with original studies, I mean, there's a ton being done in meta-analyses already. This is one that I looked into because it was in my old field of social cognition before I got sort of dismayed with it. And you can again find data repetition that you can work with, because often meta-analyses have a forest plot and they have a funnel plot. And this reproduces the same information in multiple ways, either between the numbers, plot itself, and then again in a different format over here. And all you have to do is compare them. It takes you a minute to do it, but you can find out very quickly that the numbers in this don't match the numbers in this, because this should be here, or vice versa. Maybe it's the other one. We don't know. It's not tricky. It's not really high IQ stuff, but you have to check. The difference is someone looked. And equally, like Esther Mawson's work, who I had the opportunity of joining my class like 18 months ago to talk about this type of work. Again, you can do things as simple as this effect size is what's used and reported in the meta-analysis. What is it that's in the original paper? And again, in this Vahi et al. Paper, you find 2 effect sizes don't match up with the original studies they got taken from. And I use this one because I think it's interesting, because the paper is Vahi, Nicholson, and Barnes-Holmes, and this is Vahi, the original paper by Vahi, and this is an original paper by Nicholson. So it's not like we can say they're not familiar with the work or something. Transcription errors can happen even between your original work and your meta-analysis of your original work. Okay. There are many other types of errors. If I had a complete list of them, I wouldn't need to talk to you about them. So I'll just hand wave to them. We need work to be put into this. We will be doing that. We would love help with that. There will be a hackathon on Saturday. But they can involve many other types, including inferential and argumentation errors. For example, citation errors. I was stunned to read last year that 9% of articles in citations in psychology are completely mischaracterized the claim that they're cited for. So someone says, Hussey et al. Said X, And I said, no such thing. Someone, now that I think of it, was it the Lakens effect or someone, or the ERYOR effect? Yeah, that if you write a sufficiently well-cited article, eventually someone will miscite you, like for the opposite of what you said. Yeah, so like
It's the effect
well-known Bayesian Daniel Lakens reference. Okay. Errors can be found in citations. Some of these maybe are inconsequential, and sometimes they're not. If I happen to base my entire paper around a misunderstanding or a miscitation of something, this can propagate that error into the literature. Sometimes these can be consequential. There's other classics, like the difference between significant and non-significant is not itself significant. There are also problems with things like reverse causality. I start noticing more and more around. I did my PhD in suicide and implicit cognition. And only later did I realize most of the suicide literature uses cross-sectional samples. And what it does is it uses current psychological variables as its IVs, and its DVs are historic suicidal behavior. So how I feel here and today, my whatever psychological variables predicts historic suicide attempts. Unless I have a time machine, that's not that useful an analysis. And you produce very strange conclusions from it. And this general problem of confusing IVs and DVs is common. And there's a great paper by Heiko back in 2015 that talks about it. So, to increase the accessibility and the discoverability of methods like these, and when I say methods, sometimes it's as simple as like, hey, you should add up the sample sizes. But right now we need an instruction to do that. We need this training manual to do this. And I think this would be a very foreseeable output of this project. Questions as simple as, like, what do you have access to? Is it the article, the data, the code, the goodwill of the authors, which you don't always have? Sometimes you do, and that's great. How could you get more? Including goodwill, how could you get more data? You could try asking. There are more and less effective ways of asking for data. How can you get more data than you realize you have out of plots from data extraction, things like web plot digitizer? How can you use summary stats and correlation tables to be able to do all sorts of things that only a year ago I didn't realize you could do? What could you check? Very long list. What should you check? How would you prioritize this? These are bullet points that would need to be massively fleshed out to like, yeah, I don't know. I still don't have a good answer for this. Or how would I prioritize what to check first? And Anna's work points out in most psychological claims are not even wrong, that a lot of the time when you go and read an article and you say, what is the article's main claim, cannot determine it. And that makes it difficult to know where to start. Great article, you should definitely read it. And then, of course, we need to be reflexive on this. How do we ensure the reproducibility of these checks, packages and scripts, and things like this, so that others could verify that there is indeed an issue, and how to effectively communicate these to the scientific community, right? There are more and less formal methods. Someone will get angry with you no matter which method you use, but yeah, you should know about these. Okay. These are only the methods that we already have, right? We need more. StatCheck didn't exist 10 years ago. Rivets and all the rest of them didn't either. So we're also doing some measure development, method development as part of this grant. One thing I noticed is that correlations are extremely common to report in psychological papers, and yet there's not yet an error checking method for them. Or people who are really good with stats will say, of course you could do X, or maybe Lisa has a method that I'm... Okay. That's all. This is what I need. But this is something I came across. Anyway, I came across it on Twitter. Somebody pointed out a question exactly like this. What is wrong with these correlations? And I could intuitively say what was wrong, that if this one is high and this one is high, this probably isn't really negative and small. But I didn't know the math of it at the time. Solve it with trigonometry, but it's very hard to spot. It's very hard to spot by eye. Which one of these correlation tables is valid and which one isn't? 3, 2, 1, go. No. You can't do it. Of course you can. It turns out that all I've done is I've flipped one correlation from 0.3 minus 0.9, and one of them is positive definite in that its eigenvalues are all greater than 0, and the other one is not. This one cannot be the case. This is useful. We don't use this enough. I don't know of any critique of a paper that like puts forth this as a general method we should be using. So we're doing so. We need to do more method development on this. For example, we don't know much about the statistical power of this. We don't know how much we should or need to correct for rounding, because of these are not the correlations. These are the reported correlations. And this is a general problem for a lot of these methods. And we also need to develop or make use of better methods to triangulate. It's one thing to know there's a problem somewhere in the table. It would be another to be able to say, is that correlation? Probably. And what do I mean by probably? What are my long run probabilities of getting that right or wrong? So that's all something that we're doing. We're doing that right now at the moment. And then we're going to apply it. We're doing this with Frank Bosco and one of his students using the Metabus data set, which is an awesome data set of about 16,000 articles, correlation tables, fully extracted and processed. And then we can look at what is the prevalence of errors in these. So that will be a very useful practical test and a way to start chasing these errors. And then the other part of this tool that we're building, Recover, I don't think I've said it yet, is the reusing part. So reusing correlations for both validation, but also regression. Me, in my naivety, did not realize until relatively recently that you can rerun regression analyses just on correlation matrices. If you know that because you're better at stats, you're like, yeah, duh. And if you don't know that, as every time I introduce it to some of my colleagues, they're like, what? I could do so much with that. That's so useful. And this is what I mean by it. It's not inventing any new stats. It's about making these things discoverable, usable. Yes. Being able to do this would allow me to refit the same analysis. I could reproduce these authors' analyses if it was variable 1 is predicted by these variables here. I could do robustness. I could add or drop covariates. There's some limitations. You can't, have a categorical predictors from the correlation table, but still, it's something, right? You can assess reproducibility, robustness. You can even, if you're feeling a bit bold, you can start probing their sort of implicit causal assumptions, because I talked to one set of authors and they said, we genuinely have no belief about what causes anything here. And I said, great, swap these two variables. And I can show you that you still get significant results and everything. And that was your definition that we're right because all these p-values are significant. So just completely change the configurable model, which doesn't make sense, but you say it does. So yeah, a little bit. Anyway, that's mostly the first two, but possibly even four. Make it easy. Normalize it, number 2. We're normalizing it with a master's course on error detection. In my opinion, and now others, thankfully, there is a conspicuous absence of error detection in the curriculum. The psychology curriculum, maybe others are doing better, I don't realize it. I thought I was alone in thinking this until Dorothy Bishop published a blog last November about it, saying, here is a general outline and a stated need for error detection. Is when you talk to students about this, they have a good sense of what scientists do in terms of publishing and stuff, and they have an intuition that critique happens somewhere, but it's not covered in any class. So where would they get these skills from? Normalize, in my opinion, with Minds, Behaviors, Talon, is a verb. Not an abstract concept. It means doing it. Doing it in a normal sense, doing it all the time, so that it is done and people see it being done and they participate in doing it. So this is the course estimating the credibility of past research, which has been running since last fall. One iteration of it so far definitely had some imperfections, but learned a lot from running it. And at the core of this is the idea that science is an intensely human and fallible activity. And we see it as as an act of organized skepticism. And while this is just one course right now, I mean, we've gone from one course and Dorothy's call to eventually we want to be able to put this curriculum out to make it more public, to say this is at least a template for what you could do and you could pick it up at your institution and it is viable and the students like it and they feel like they learned something. So why not, right? So how did you get so good at this? Ask Nick or someone else. Practice. Those practice. Especially with stuff like this, that's not really high level stuff a lot of the time. The general syllabus that I ran last semester looked a bit like this. We talked about a heavy front end on the functions of science other than truth discovery, right? Because it's fun. We like doing it. We like asking and answering questions. Sometimes we like asking too much and answering too little. And, the fact that we all have to put food on the table, things like this. Bernal writes some fantastic things about this, and he did it in the mid-20th century, and we've forgotten a lot of them since. And I think we should read Bernal more. I covered a lot of these slightly more automated, or at least R-facilitated and code-facilitated ones, like pcurve, statcheck, grim, grimmer, sprite, and recover, the one we're developing. I should also note that, who developed the R libraries for Grim, Grimmer, StatCheck like this? StatCheck they did themselves. The rest of it is a master student called Lucas Young, who now works in IT. And I could not convince him to do a PhD with us. He said, no. None of that, thank you. No. So again, slightly a group of outsiders and weirdos, but making some incredible contributions and letting the rest of us run with this stuff. We covered those tools. We also talked a lot about recomputing results from summary statistics. I am still learning by the day how much you can recover from those. Things about effect size plausibility. The usual, you see a meta-analysis and it's got Cohen's D's of 4 in there and you wonder, how is this not spotted before? And also things like reliability corrections. So if you know there's a meta-analytic or even observed correlation between two variables, but you also know the reliability of those variables, you can disattenuate it and see, is it plausible? And I again did that with that Vahi meta-analysis. And if you disattenuate the task under some reasonable conditions, all of the correlations are more than one, which tells you something's wrong, right? It can't be the case. Someone needs to be wrong somewhere, and now we need to start looking where. The utility of that is how easy it is to check. It's not trivial, but it's certainly not as hard as replicating the whole thing or starting from scratch. We talked about meta-analysis biases and bias detection and its failures. It's usually like a risk of bias, I should have said. And risk of bias all too often, unfortunately, omits like obvious factual error. Right? I can fit nice fancy models and selection models and ways to correct for bias. But maybe I should just read the original study and see if it passes stat check. If it doesn't, I need to weight it differently or I need to consider things like that. We discussed lots of causal language and missing causal language and causal claims being implied but not made and what you can do with that. We discussed construct validity evidence, spotting nominative fallacies, jingle fallacies, jangle fallacies, and how that can help you interpret the utility of a given paper. Obtaining and extracting data, and communicating errors and examples of critique. That involved basically reading a ton of PubPeer comments and having them, or critique papers, post-publication critiques, and also having them write dummy post-peer comments that I kept having to flash warnings on the screen, like, do not post the comments, like, it's only to me, not to PubPeer, we're not there yet. Yeah. So this was not just information given, this was practice. They did exercises each week involving these activities. You're probably, some of you, aware of Sanjay Saristova's Everything is Booked syllabus from 2015 or 16, right? Really popular syllabus. Malta and I have both taught courses structured around this concept of we've got problems here and we've got problems here, and it's many crises and many problems. And we've taught them for a few years, and students get that there's an issue, but not the skills to detect it themselves. So we still run those there is an issue as a series of crises classes on the side for awareness. And we get in great speakers, and if you'd like to join, But this is not about awareness so much as it is active participation, right? Organized critique, and actively practicing each of these skills. Probably the most useful thing I could tell you about this class and my experience running it was that I immediately encountered some issues with the students. So basically, week one, I put like a Mentimeter poll, where they can give answers in real time. And I said, like, are you aware of the replication crisis? What percentage of published psychology studies do you think replicate? Have you seen numbers on this? Is it just your intuition? Generally, like, how big a problem do you think we have as a field? And I was really surprised because most of them had not taken our class or even heard of our department, because we're like a new department at the University of Bern. Because they still said, yeah, we got really big problems. Nothing replicates. My faith in the field is very low. I was like, okay, this is encouraging. At least I don't need to blackpill them. Encouraging in the sense of I need to get them off the false pedestal first to be like, we do have a problem. Not encouraging to the normal person. I thought at least I have less work cut out for me here. And then I gave them a written assignment where I had them read some Bernal, and they went off and I said, why did this person do this paper, even though it's obviously not the case and stuff like this? And what did they do? They wrote, everything is fine. Science is self-correcting. Everyone's trying their best. And so I just sat down with them next week and I said, guys, what happened? Were you just like demand compliant last week? That you were like, oh yeah, no, everything's terrible, whatever you want. Or like, what's happening? And what they said was, we believe we've got a lot of problems, but we have no idea how to say so in a written context. We have written essay after essay after essay that takes these things on as face valid. Our writing style is all about the edifice of science is la 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 la. And I had to very explicitly say to them, you don't have to do that here. I want to hear what you actually think. I don't want you to critique in lofty terms. I want you to tell me what's wrong with this given paper. And I've pre-selected these papers as having something wrong. Please find it and tell me. And it took several weeks for them to realize that they genuinely had permission to critique, to find errors that weren't just like greater sample size. And to find that language, to find the words themselves to critique. So aside from needing to write a handbook and expose people to existing critiques and the methods of doing so, a lot of this is just equipping students and our early career colleagues with the language of it and the permission to do it. And if you run a course like this yourself, that would be my main take home. Exposure, practice with language and permission. Then lastly, make it rewarded. A lot of this will be, the overlap between these is not perfect and not nothing either. Some of those methods will be used in this program, but some won't because we usually have access to the data. The core of the ERYOR grant that funds this venture is this part here. A bug bounty program for science. Bug bounty programs are taken from technology, right, software development industry, where basically Google says it's way cheaper to pay the hackers that are out there and are going to start probing our systems. It's cheaper to pay them off to say, show us a really big flaw in our system and we will pay you money to do that, than for them to say, I'm going to earn money by breaking into that system and causing havoc or whatever. Okay? So the bounty in this case is for the bugs, not the person who wrote the code or anything like this. It's bug bounty is paying people to find bugs, not to pursue people. Okay, what is this? At the core of it, a handful of slides. It's 250,000 Swiss francs, which is about that in other currencies. And we are going to check roughly 100 published articles, initially in psychology and then maybe beyond, for errors. already published articles pre-selected by the community at large for their importance, broadly conceived, and whatever that means. And we're going to pay authors and the reviewers a base fee to allow this to happen, and then an extra incentive contingent on what they find. So the worse the error they find, the more they get paid. And the fewer errors, this is the reviewer, and the fewer errors are found, the more you get paid as an original author. How much are we talking here? These are indicative amounts, but this is what we're working with at the moment, and it will also likely be scaled for regional differences. Authors and reviewers will be paid 250 francs, very roughly converted just by the same numbers into your own currency. It's about 250 either way. 250 francs just for participating. This can scale upwards for the reviewer if it's a particularly complex project, or we think they have like hard to find skills or things like this. We have flexibility around this. And then the bonus rewards are up to 250 again for the author and up to 2,500 for the reviewer. The argument here basically is that the authors have already been paid to do this work. They've been funded to do it. They've been paid their salary to do it. Whereas reviewers, yeah, it's usually beyond what they usually do. Our top line goals for this element of the project are to explore and test the practical challenges of doing so, because it's never been done before in science, as we know. And the tricks the issues we run into with implementing an error detection system like this. Second, we want to estimate the cost-benefit ratio of doing so, of paying people all this money to check for these errors, compared to what would happen otherwise. And that's the key bit here. It's not there is an opportunity cost involved in not discovering errors and continuing on as if these papers are sound, remembering that they are pre-selected for being important or influential. Our continued collective misbelief that they are sound has costs, and we would like to try and estimate that. And then lastly, to obtain empirical estimates of the types of errors made and the frequency, prevalence of these errors. Yep.
I'm curious for the cost-benefit ratio being one of the potential huge benefits to me would be if other researchers start changing their practices in anticipation that if something like this existed, they could get caught in the future. Do you have any way to try to measure that, or at least model hypothetical versions of that in the cost-benefit ratio?
Math is nodding, so I'll let him answer.
Yeah, so I mean, right now this is kind of short-term funding, right? In 4 years, this project is done, and we'll see then if it more. So I don't expect people will change their practices because of what we currently have. They might if we can present a vision that's more long-term. That being said, I am in touch with an economist in Bern that does these types of counterfactual analyses. I don't know how to do them myself. I have an idea how to do it for more immediate cost of building your own research on your own newspapers, and also not pursuing other research that's, I guess, less erroneous. But yeah, these types of even broader changes in practices, I don't know.
I don't want to derail things, but can I answer?
Yeah.
And one thing I'm thinking is when the Reproducibility Project paper came out in 2015, I think one of the potential benefits of that, to what extent it's been realized, I think is a really interesting question, is putting the fear of God into journal editors, that it'll happen again. And even if editors or other stakeholders didn't think of that themselves, performers can use it to say, hey, there could be this project again in 10 years and your journal could be targeted. So if you guys had a meta paper like that and it got a lot of attention, even if people didn't instinctively, just naturally, spontaneously start to be afraid of that themselves, it could be used. It could be a useful tool to say this kind of thing is existing and it's going to scale. And
yes,
I don't know how you would ever measure that. I could imagine maybe it'd be possible to model with a bunch of assumptions.
Yeah, I think you could measure it, but you could probably do some agent-based modeling. Well, I can, but I mean, Richard McElreef is on the board, and maybe I can convince him to look into this as well.
But what about just a basic paper of measuring computational reproducibility of the field? In the word,
Basic is basic is a key word. I mean, Alta's published on this. Lisa, you published on this, right? Or is it the same paper? No, your one with
the psych science.
Yeah,
paper? Yeah.
Oh, sorry.
It's bad.
Real bad, terrible.
Very bad.
Yeah.
Yeah. So we did this with just one issue of psych science, where every paper got all of the badges,
Right.
and we weren't able to reproduce.
It was one of 14.
Yeah, one of the 14 we were able to reproduce. So yeah.
Let me say that I absolutely agree, right? That would be my hope here. Why do we all pay our taxes? Because we're upstanding citizens, blah, blah, blah. No. Because of the contingency that you might get audited. There is a chance someone might actually look. Or, I'm speaking to a less American audience. But if businesses pay their taxes, because they might get audited. Right? Individuals don't need. But you take the point, right? I was trained as a behaviorist. I see the world through the lens of these contingencies. The even small chance that people might look, I think, is useful, right? We do the same thing with pre-reg all the time. It's not that it guarantees that no one deviates, but it makes it accessible in principle, and there's now a realistic chance someone might look. And I think that's important.
I think that's sort of the achievable long-term goal, is that large science funders, like in Switzerland, the SNF, or the DFB in Germany, of the
NWO
in the Netherlands, they could take a tiny fraction of a percentage of their funding and say, we'll do random audits of projects we already funded in the past. And I think that would put the fear of God into people who got funded, because they knew someone's eye could look at them and found it.
And to do that, I think most funders would want to see a plausibility trial.
Yeah. So,
and that's why we're here.
Sorry, can I? Wouldn't the ultimate end goal be that individuals are so afraid that they would use them preemptively to check their own data? I mean, is that eventually what we would like?
Yeah.
I mean, you kind of assume they do that already, right?
Yeah.
But still, errors happen regardless.
Yeah.
Of course, you can be diligent, but
Sure, but I mean, for example, this handbook that you're talking about, I mean, maybe you should call it like how to find my own errors rather than somebody else's errors, because I think
it's a general skill, right?
Yeah.
It's a culture of error awareness, error acceptance, error correction, without catastrophizing that these things will occur. We'll come back to that point in a little bit, and I'll try and move on a little bit. Okay. So how would the process work? We select candidate articles selected for importance, very broadly conceived. Would it matter if this was wrong? If there was an error in this paper, you can self-nominate. We strongly encourage people to self-nominate to us. That would be awesome. And equally, you can make suggestions, but yeah, it's a process. Generally recent, because we're kind of looking for ones where we could get access to the data and the code, because that makes error checking far more effective. And we can go deeper on those. So maybe within the last 10 years. And yeah, suggestions welcome. Unfortunately, not randomly sampled. We'll come back to that why. That provides issues then with estimating the prevalence of these, but it's important for other reasons. And attention paid to factors like gender balance of who we're inspecting, who's doing the inspecting. Okay. Once we have a candidate article, and we have a few examples of these already, we then seek the consent of the author to inspect their article. So we say, hey, this is the nature of the project. We give them an explainer. We say, we would like to check your important article for errors. Noting that it has been selected because of its importance to the field and not any a priori belief about that it contains errors. And we're not going to charge you anything for it. We're going to pay you. And this involves a pre-commitment, an important pre-commitment to sharing materials, answering reasonable questions, professional conduct in dealing with reviewers, as in any other context, and acting, most importantly, acting on the recommendation of the recommender. That's, for the moment, just me. Not acting in isolation, but as in there is only one recommender. Then they are matched with a reviewer. So there is an analog to the peer review process, but with some very important differences. Feel free to volunteer. You can do so on the website. It is non-anonymous. You will be in direct contact with the authors. You cannot, unfortunately, it's not pragmatically possible to keep you anonymous. And you will be able to ask the author reasonable questions. And then we may need to mediate what constitutes reasonable at times. And again, prior commitment to professional conduct. The reviewer writes an error report, which then gets checked by the recommender, who acts like an analog of an editor. Claims have to be obviously substantiated, goes without saying. And the recommender can ask to modify, correct, or edit this error report for like brevity, content, tone is absolutely necessary. We also envision that there would be two sections, two broad sections, error testing sections or error checking sections, and then sort of broader critiques. This would be nice to have a forum for broader critiques of work, but equally we need to be clear to stay in our lane. That this bit about errors is what we're primarily considering, and if you want to have a broader discussion about merits of the work or something, great, but we can't be responsible for that. After we receive and we edit and debate with the check the report with the recommender, it goes on the website. Okay, not delayed, not after the authors respond themselves, but once it's been vetted on our end. And it is published under a CC BY license. So you can do anything with it. You can turn it into a critique article and submit it for publication. You can make it a public comment. You can tweet about it. You can do whatever you want. Right, this is an important difference from peer review. Of course, authors are offered an opportunity to reply, to write a reply to this error report, totally optional, with the gentle requirement that it be timely, because sometimes people really draw this process out so that the critique never sees the light of day or doesn't for a long time. We want to avoid that. Again, published on the ERYOR website. And CC BY license, so you can again do whatever you like with it. And then the important part is we make the recommender, me for the moment, makes a decision and any associated recommendations on the basis of the error report, insofar as it can be substantiated, and any reply by the authors. And this is possibly in conjunction with the advisory board, which is why we have them, so that it's not one person acting alone. So what decisions can be made? You're all used to accept, minor revisions, major revisions, reject, things like this. Instead, because this work is already published, it needs to be modified a lot. We say no errors would be great. No additional action beyond the publication of the error report on the ERYOR.Review's website. Minor errors, bearing in mind that this is what we expect to find in the vast, vast majority of cases, and that it does not fundamentally undermine the scientific contribution of the work, right? It is incredibly likely that every work we inspect deep enough will have some minor errors in it. And all that we ask is that the authors appropriately acknowledge this when they discuss the work in future, right? Indeterminable errors is the next level up, which is to say that no determination can be made. And we think that this is a worse determination than minor errors, because at least in that case, they are verifiably minor. And in this case, we say, we just can't make a determination. Maybe there's inadequate access to the data or code, or after the person agreed, the data goes missing, or it wasn't as obtainable as we initially thought. Yeah.
Yeah, sorry. I'm not sure how you big way. Spell this for me. The authors get paid a base fee, and they get paid more depending on how few errors there are. I'm wondering, why not the other way around? Like, I get that it's basically what I can see that people have to do more work, the more errors can be made. So I'm wondering what.
In some world, I could understand what you mean. It's like a payment for work done, but it's a very perverse incentive to pay people to make errors.
Maybe they should have done the work before.
I doubt it's enough that people. Yeah, I doubt it's enough that people would say, "Oh, my." So let me submit it so that they can bring this to life.
I totally agree.
Yeah, but
I totally agree, but it's a very hard sales pitch. If you take this in future to a funding agency and say we're going to pay people more for making more errors, I don't think it's politically viable. I understand what you mean, but the optics are terrible. I will have to move on. Okay, moderate errors, and the sort of criterion for this is that it might be the sort of thing that requires a minor correction notice to be published. Again, we don't have control over doing this. We cannot unilaterally publish a correction notice. We are recommending to the authors that that is what is done and that this will be publicly said on the website. But ultimately, it is up to them to act on this themselves, right? It's not that we couldn't also contact the journal, but we are not the journal. This is not the publication of a correction notice. It is the recommendation that one be published. Major errors goes up to like a major correction or something that might warrant an expression of concern. And severe, we would retain for, where we would recommend that the article be retracted. So how does this link up with the bonus payments? It looks something like this. If there are no errors at all, the author gets a bonus. If there are minor errors, both the author and the reviewer get paid because we want to normalize this. We want to normalize a culture of error detection, acceptance, correction to say, yeah, most research probably has minor errors. And now you have been checked and can say confidently, the only errors we found were minor. And this is what normally happens on time.
Sorry, maybe I misunderstood. But so if in case of no errors, the reviewer does not get paid?
Yes.
No bonus.
No bonus.
Oh,
you always get the base fee.
On the, okay, sorry.
This is on top.
The fee,
Yeah, yeah.
250 is still stays. Oh,
Yeah.
sorry. That makes sense.
They always get the base fee.
Okay.
Everyone gets a base fee. These are the bonuses on top. And then it scales upwards as you go to indeterminable, because that actually can be quite a lot of work. Moderate, major, and severe errors. Yeah.
Instead of error correction, I'm surprised that you don't think minor errors should be corrected. And obviously journals have different standards there, but wouldn't you want corrections of any errors?
In what world and to what end? I expect personally, my subjective guess is most things we look at will require a correction notice. I don't think we could sell the political viability of this to people to say, hey, do you want to participate in this project? You'll definitely get a correction notice. Also, journals will not look kindly on it to say, like, these people are pumping out like dozens and dozens and dozens of correction notices. So maybe in some perfect utopian world where, but for the moment, I think the political viability of this is only if they meet some bar where it feels like this is substantive enough that it needs to be said. And otherwise, we can trust the authors to communicate that themselves appropriately, right? And it's just a recommendation. It's not like the authors, if they have strong feelings about this, can't say, I'm going to do this unilaterally. I'm not comfortable with those errors. Yeah, Lisa?
It's between major and severe errors. And I'm concerned that it's about hypotheses.
The boundary conditions of these are really defined by these.
Right, but what is a major correction notice versus a retraction? I often see that people think they should retract something if the error causes a different conclusion and not if it causes the same conclusion, even if it's an equally severe error.
Yeah.
The same error.
I think it would be very difficult to say in the abstract, not having checked them, right? We expect major heterogeneity here. We have a board of folk to help us with these decisions. I wouldn't like to pre-commit to like, this is exactly it, right? It'll be an iterative thing. That's a bit of a dodge, but I also think it's a fair, I wouldn't want to define this in such an inflexible way that it couldn't meet the realities of doing the work. Let me just move on to the end and we'll take the final question. Okay. Oh, I was actually so close to being here. Yes, this is our strategy. I think it worked for Brian Nozick. I think it could work for us too. Make it easy, make it normative, make it rewarding. Up to somebody else in the future, make it required. This is a project that is already in flight. It's not a hypothetical. It has been funded. We already have candidate articles. We have some agreements. We have people who are willing to review for us, including Lisa as our first. And we're excited to continue. Please consider joining us. You can nominate your own papers. With some care, you could nominate other papers that you find to be influential in the field and not for other reasons. And you can offer to be a reviewer as well. And check out FAQs, extensive FAQs on the website on error.reviews. Thank you.